This afternoon we'll start with a discussion by Dr. Francesco Celani on further progress developments on surface bulk treated Constantan wires for anomalous heat generation by hydrogen and deuterium interactions.
Okay, thank you. This one, because I have some problems with my teeth of operation, it will be difficult to speak. So sorry, but that's my pain. Okay, this experiment was started in order because we have several open questions about the last year presentation. Mainly it was some mistake around. So we make a lot of calibration in order to be sure nothing wrong happened. Moreover, we have some nice present because of just experimentation. This one, number two, we have an unexpected water splitting phenomena because we prepare our wire in a special procedure to get nano-diamantoids from the space. Moreover, we get another present. We get a giant resistivity thermal coefficient changing when the resistance ratio of the wire changed. That one we make a measurement under vacuum with loaded wire because to avoid possibility that the gas inside can fail. And again we recomplement the result. Number five, we want to understand which one are the key parameters to get HSIT. So, according to the result, it is one key parameter is the flux, and it is the same parameter found by NASA people in 1989. So maybe the later people NASA will join me. Okay, Frank. Okay. Anyway, it was the first scientific confirmation about the reality of cold fusion. 1989 at NASA. Okay. We used the Constantan. The main reason is this material means nickel copper alloy, the red copper, have extremely large value of the possibility to decompose the hydrogen from molecular to atomic. In comparison, palladium 0.42, nickel 1.74 electron-volts. Constantan typically from 2.5 to 3 electron-volts or more. So really, very good materials for our purpose. This is the old reactors in now in use, and they show last year during the presentation in the United States and later in Korea. So just glass tube, 20 cubic centimeter, with two wires inside, one reference, one negative. Is Constantan with the surface modified in order to have a sort of multi-layers, sub-micrometric multi-layer. This was the first calibration by inert gas argon, so the resistance ratio in the right side increasing the power a little bit as expected. So with inert gas, nothing strange happened. All what we expect. When we add hydrogen instead of argon, we make a mixture argon-hydrogen. We observe that increasing the temperature to inert wire in order to know more or less exactly the temperature of the active wire. At the beginning, the resistance ratio increased, like in argon observed, and later, when overcome 125 degree abruptly decrease. This is the phenomena that we observed. Some months before, we went to know that such phenomena was discovered from German people in 1987. They publish in a very complicated way, but they don't realize that it was useful. This is the life. They published in 1993 from Dresden University in Germany. I know only few months before. This is another cross-check of the temperatures flowing time, the internal temperature increase, and the external temperature increase. They don't depend on room temperature variation, so it's a real phenomenon. Flowing time, the resistance ratio increase, and when we stop for a short time, we have a value as low as 0.71, very large looking. This graph is the main graph that makes people worry that we make some mistake, and ourselves too. Decreasing the pressure in green, the chest power increase. When we make step process increase and decrease until stable. Here we stop. So there is some strange possibility that the gas inside the chamber can affect the anomalous heat production. Because this we spend over two months to make a lot of calibration, to be sure. We use we make two different experiments with the platinum wires with two different reactors. The first reactor, the same used during the demonstration in the United States and Korea, and the later, some months later, because this one was broken, we have to build another reactor with the new meter, new everything, and check again about calibration. Anyway, even changing the reactor, meter, so on, quality results were the same. So there was no systematic error in the system. In short, we used two kinds of wire, one thin, 100 micron, another, four wires of 50 micron in parallel to simulate our Constantan wire is 200 micron. All what we get about temperature value is all what we can expect in inert material, inert system. Nothing strange happened. So the local temperature is higher with the thinner wire, and the local temperature is higher when you use insulation or low conducting glass. So all what we get was as expected, and the most important point C. When we reduce the pressure, we get increasing of a temperature inside the chamber and decreasing outside. Because we make our calculation using temperature outside the chamber, our data last year were underestimated, not overestimated. Is calibration, moreover, because the platinum is ideal thermometer, we can know which one is the real wire temperature, local wire temperature, mean legal. So it is important to know at which temperature the reaction starts. This is with 200 micron wire, so at 48 watt under vacuum, 550 degrees about. And with the thinner wire, the temperature is higher, 700. All what we can expect. This is the key experiment that show reducing the pressure, helium conductivity similar to hydrogen, internal temperature, fractional sample increase, while temperature, internal chamber temperature increase, but external decrease. At this time we want to check there is some effect of a long time at some pressure, low pressure, to check some strange effect, but nothing. So the data are really good. This one is the unexpected water splitting phenomena we get last December. We were using two Constantan wire, one with 2 layers, we call nanodiamantoids, and the other about 400 layers. We give, it was the first experiment, we give power to the 2 layers wire, to use like a reference to clean the chamber, the gassing. But we observed, with our big surprise, that when we give power, the resistance ratio of the wire decreased. So it seems really unclear. An increase, it was 10 watt under vacuum, and it is to 15 watt, and moreover, the same effect. So I stopped to be sure nothing wrong happened. I checked connectors, everything I can check. And it was stable reduction of resistance, like a loading. And small effect also in the wire that don't went to very high temperature. Later I give the same power. I don't see my eyes not good anymore. Okay, at 15 watt, in the later 20, and at the end I stop again. So what we can see that under vacuum condition with Constantan wires, with nanodiamantoids, it's possible to decompose the water. Was very big surprise. Here is a possible reaction that happened, but more work is needed. This plot is done under vacuum conditions, so no gas effect. This is the value of traveling wire with the local temperatures, so you can know which one. And we make 3 experiments. The first one is the experiment of water splitting after a short time, after 5 hours of experiment. And in violet are shown the HS power calculated in a linear mode. Difference between external temperature minus room divided input power. So sample at 10 watt, the first loading, the first spontaneous loading at HS 1.28 watt, and increase up to 2 watt at 20 watt of input power. Sorry. Later we make loading a lot of cycling, and at the end we add even acetone in order to have some carbon on the surface of the wire, and repeat the experiment. So later we were more confident, so we go up to 30 watt under vacuum, so the local temperature is about 500 degrees, and the chest power was about 4.2 watt. So the chest power increasing the wire temperature. So it's positive feedback. So we learn a lot of key parameters. This one was another big surprise for us. We observed that sometimes the resistance drop between high and low temperature was very large. So we collect all the data that we can get several months of experiment, and we put all together just to have a view. And we observed that basically temperature coefficient of the wire has a very big dependence on resistance ratio. Means the amount 3 minutes. Okay. Key points. When we go make the same experiment, even at the liquid inversion temperature, the value of increasing was really large. I have to run. Okay. Maybe I will. This experiment is the experiment that shows that the key parameter to get the chest heat is the flux. In this experiment, we intentionally before loaded and after deloaded the wire with a very low pressure inside the chamber, 0 to bar, and after apply current to the system. So the wire deloaded this resistance ratio, and we observed, correlated, that this is the zero level of power. When there is a steep decrease, steep of the curve, or the loading curve, the chest power increase. When the curve was more smooth, it decreased. This is, I think, very clear demonstration that the key parameter is the flux, as discovered from NASA people 24 years before. Here the system was almost deloaded, and there is even small chest heat, just oscillation. So I think it's a really simple demonstration, the flux, how it's important. And Mike Vecubre was the first to stress about, you know what it is? To make a formula, 10D formula about the chest heat, flux, and loading.
Francesco,
Okay. Yes.
was that power in the upper left corner? I couldn't read this there. Francesco, with the upper left quadrant there, what were you plotting on the y-axis? The green.
Okay,
curve.
this is the zero level. So it is here is almost zero.
Is that power?
HS power, difference. Is you have to, I get this data before coming here to make it more easy to understand, but really before a flight go, so, okay. But I think it's really the most important result to get. Here there is explanation, conclusion. The material, the cold fusion is material science. So good material with the proper geometry, and moreover, how you make the experiment. The flux is really fundamental. It's the reason of cold fusion. We have a chest heat during the loading and the deloading of hydrogen inside the lattice, the same that they get NASA people. So really, coincidence of what we have found. Several people detect this kind of behavior, but I want to make really in a straight way, to be completely sure. And Mike Vecubre make a formula, KD formula, this one. So I am glad to Mike. Several people try to reproduce our result, especially multi-fluorescence group, and other in the world, 10 people. So I am glad to them because they work for me. I just give why, they give me information back, I can improve the experiment. So I am glad to them. Cold fusion is dynamic effect, not static. So if you stay in the static condition, you get nothing, even if you have very large load. 1 minute, okay? I have to go. Sorry. The role of nanomaterial as developed from Arata is reconfirmed. Takahashi, the Mure group, have nice result with a Constantan-like material. It's called Constantan family, so copper nickel family. So other reconfirmation, multiplication have good data, codecs in STM, they get loading and the flux, so it heat. So all the plans are needed. National give us a lot of help, material, so on, so I am glad to share and be several projects this year at other plant. Really, we can make progress because the open science philosophy, and I want to thank all the brave researchers that help us to improve. Thank you very much. Now, people, I want to thank you. Sit down. Dr. Franic. He was the first and they was great contributor, according to me.
Well, thank you. We are a little behind, but if there's a really fast question and answer, we can do that before we miss. Yes.
In April, you mentioned that you had an explosion with a cell.
Yes.
Do you understand now why you had?
Yes, it was like we had several explosions. Okay, happened. One is due because we want to load the Constantan at low temperature, and we get explosion at -50. So we don't know why, but later we understood. So when you make a loading at a very low temperature under hydrogen, there is some critical temperature. So okay, technical problems. So you have to be very, very careful, even at very low temperature, if the wire is active. When we make calibration with helium or inert wire, nothing happens. So the Constantan have several strange data. We have to study more. Okay.
Well, thank you. I'm afraid we'll have to cut.
Okay.
It's just our time requirements for the session. So thank you again, Dr. Celani.